Hey everybody, welcome. We are going to look at some more parabolas. If you for some reason missed the previous lesson about parabolas, feel free to go back and watch that video. We are looking at specific parts of our parabolas, key features here. So we are going to look at finding the minimum or maximum value of the function. We are going to describe the domain and range of the function and where the function is increasing and decreasing. So we have the same little chart over here to the right, and this is what you use when you are in standard form, like ax squared plus bx plus c. And this first problem, this h of x, is in that form. So that tells me I gotta use what I've got in the box here. Just to go through it again, all the green stuff is an x value, negative b over 2a. It's the same x value that they use over and over again. The blue that I highlighted, f of negative b over 2a, that is a y value, and it's again going to be the same y value that we use over and over and over again. Real quick, I'm going to find those two main numbers that we're going to use. So again, in green, I've got the x value, negative b over 2a. I am looking at the a and the b based off of this format. So for us, it looks like a is 2 and b is negative 10. So negative b, negative 10, is a positive 10 over 2 times a. My a is 2, so 2 times 2. All right, so we got a 10 over 4, which you can reduce the fraction down to 5/2, or you could put it as the decimal, 2.5, either way. I think I'm going to stick with the fraction. And then we need in blue here the f of negative b over 2a, so f of 5/2. Again, this one is actually an h of x function instead of an f of x function, but that's fine. It just means that we are going to sub in a 5/2 in for the x. So we will get a 2 times 5/2 squared minus 10 times 5/2 and plus 8. So all the x's got a 5/2. You can put this in the calculator, whatever works for you. I'm going to do it just step by step here. This is going to give us 2 times, and then 5/2 squared is 25/4 minus 10 times 5/2 is going to give us a 25, and then plus 8. Okay, I can reduce this fraction. 2 goes into 4 twice. Okay, so 25/2. If I turn these all into halves, negative 25 would be like negative 50 over 2, and positive 8 would be like 16 over 2. So if I combine these all together, 25 halves minus 50 halves, so I'm at negative 25 halves, plus 16 halves, I'm at negative 9 halves. Again, you can do this decimal form, or you can even just plug it into the calculator, and it honestly would do that for you. But we have now the two main things that we needed. So for the minimum or the maximum value, I do recognize that this a right here, 2, is a positive number. So that means that I've got to have the parabola facing up, which means there is a minimum. There's this lowest value here. There is no maximum. It would have to be facing down to have a maximum. The minimum, I'll just call it min, is the value f of negative b over 2a, which we actually just found. It was our negative 9/2. There's our minimum. The domain and range, I don't know if you guys noticed, but the domain is all real numbers, like every time, on all of these parabolas. So domain, I'll use my little symbol for all real numbers. And range has to do with y values. Okay, so again, I'm in this category over here. My a is greater than 0. So the range, you can write it in two different ways. You can either write it as a interval, or you can do it as an inequality. So I think I'm going to do an inequality right now where y is greater than or equal to, it's everything above this point here. And the y value of that point was your negative 9/2. Okay, so it's everything greater than or equal to the negative 9/2. And then They also need increasing and decreasing. For that, we give intervals. Okay, I'm gonna have to get rid of some of this here. Give myself some space. Okay, so the increasing. Now, we always read left to right. So as I go on this parabola left to right, it actually is decreasing, it's going down. And then once it hits the vertex, it is now increasing, it's going up. So I am increasing from a certain x value here, and then forevermore to infinity. So we are going to go from the x value, 5 halves, to infinity, meaning from this spot and forevermore, it is increasing. And there is some information down here about the parentheses and the brackets. When you use parentheses, that means that the n values are not included. If you use a bracket, it means that value is included. So I have parentheses on both of these because it is neither increasing or decreasing at the 5 halves or the infinity. Okay, so we are going to then look at the decreasing interval. And again, I could write it as an interval or an inequality. I'm just doing intervals. And this is decreasing at the very beginning here. Again, I read left to right. So I'm going to go from negative infinity, everything out here, negative infinity, all the way up to this vertex, which again, I'm looking at the x value at the vertex, and the x value for this vertex was 5 halves. So from negative infinity to 5 halves, I've got parentheses on both of those again. Those are our increasing and decreasing intervals. All right, I think we found everything they needed on number 3. What's different for number 4 is in factored form. So if I want to use all the same information that I have in the box over here, then I'm going to have to turn it into standard form. I'm going to distribute x times x and x times negative 7, 3 times x and 3 times negative 7. And then keep in mind there was this negative out here. So I actually have to distribute that negative to each of these as well. And then I need to combine my like terms. So I get a negative x squared plus 4x plus 21. Now, we're kind of where we were on number 3, where they have it all in standard form, and we can then use this little box to the right here to get all of our information. The a is still going to be the value that's multiplied by x squared. So in this case, my a is actually a negative 1. And then the b is what's multiplied by your plain x, so it's a positive 4 for b. And we can go ahead and find what x is, the negative b over 2a. So a negative 4 over 2 times negative 1. So negative 4 over negative 2 is a positive 2. All right, we found our x value. It's not even a fraction. Okay, so I have to sub this x value into the equation here. So I'll have a negative 2 squared instead of negative x squared, plus 4 times 2 plus 21. Keep in mind how I used my parentheses around the 2. Whenever I sub a number in for x, I put parentheses around that number. So that gives me a negative 4 plus 8 plus 21. All right, so negative 4 plus 8 is 4, plus 21 is 25. Okay, so we have our 2 big numbers that we needed, basically an x value and a y value. So to answer this question, I'm going to do the either minimum or maximum. And in this case, the a value is negative 1. It's a negative. So we are actually in this section over here. It's facing down. So I don't have a minimum value, like these are going down forever. I have a maximum value though. This vertex is going to be the highest point on this parabola. So my max is at the y value, which we already found is 25. So I will say my maximum is at 25. Okay, so domain and range. The domain, again, whether it's facing up or facing down, you have a domain of all real numbers. So I'll use the little symbol for all real numbers. The range has to do with y values, and we do have a highest y value of whatever that vertex is. So here's our highest y value of 25, and in this case we're going to go everything below that vertex. So I will say it's all the y values that are less than or equal to the 25. And then increasing and decreasing. So again, I like to put these as intervals from where to where. So my increasing interval, if I'm going left to right, it actually starts increasing. It's going up until the vertex. So the left side, negative infinity, it goes left to right all the way up to the vertex, which has an x value of 2 in our case. We found that our x is 2. So I will go from negative infinity up to 2, and I've got parentheses around each of those like I did last time. Decreasing is going to be another interval. It's talking about x values again, which you can see that the increasing and decreasing section is all in green because you're using an x value. We are going to go from whatever this x value is for the vertex, and there forevermore, so on to infinity, it is decreasing. The x value we found was 2, so from 2 to infinity is where we are decreasing. All right, so this is key features of different parabolas. That chart might be helpful for you, but make sure you find those 2 key x and y values. All right, have a good day, you guys.